Alrighty. While number 12 was a nice layup, a nice easy one, 13 is not so nice. 13 is I think a part 3 trig problem on a Regents, and the part 3s and part 4s are on the more difficult side, so let's take this one in stride. It says, as modeled below, you got a movie projector. There's the projector, and it's projecting a movie onto a large outdoor screen. And this looks like it's the screen because that projection is what's getting traced out by those dotted lines in that angle. Okay, yeah, that's the screen. Great. The bottom of the 60-foot tall screen is 12 feet off the ground. Okay, so this must be the ground. It says the projector sits on the ground a horizontal distance of 75. Horizontal is a left and a right motion, and they've already got that filled in for me. In fact, they've got everything filled in. And it says determine and state to the nearest tenth of a degree. We'll do that rounding later. The measure of angle theta, the projection angle. How are we gonna do this? Yeah. Okay. All right. I see how to do this. So what we're interested in is this angle here, and to get that angle, we're gonna have to do some trig. We're gonna have to do it 2 times, because trig, at least the trig that we know, can only be done with right triangles, and unfortunately, this angle here is not a right angle. Maybe it looks like it is to you, but it's not a right angle. So there is no direct way to figure out this angle. We're going to have to come at it indirectly. And I'll say it now. What we're going to do is we're going to draw 2 right triangles. We're going to draw a big one that will let us figure out all of this angle, and then we're going to draw a small one that will let us figure this little angle. And if I subtract this little angle from the big angle, that's how I'm going to get the remainder of the angle of projection at theta. So that's how we're going to do this problem. And if you're a little unclear about that, maybe you want to pause it, ask a partner or myself. But if you're like on board with this, you're like, oh yeah, that makes sense. I like that strategy. Let's just keep on going. And let's just pick a triangle to work with. I'm going to pick the small one. I'm going to pick this small right triangle here. And I'm just going to redraw it so I get to keep track. I know it has a height of 12, it has a length of 75, and I'm going to call this x. I'm looking for this angle. So I know this is the opposite, this is the adjacent, that's a tangent inverse because I'm looking for the angle, and it's going to be the opposite 12 over the adjacent 75. So if I type that in, that will tell me the measure of that angle. That would be the inverse tangent of 12 divided by 75. And I expect to get a small angle, and it is. I'm going to round to the nearest tenth. It's going to be like 9.1. But you know what? Let me just throw the 3 digits out there. So 9.090. I think that's what it was. Yeah, and I'll round at the end. That's the safe thing to do, is round at the end. Okay, so I've got this angle. I've got a nice check for it. That's the 9.09. Now I'm going to find this larger angle by doing this entire big right triangle. Let me get that entire blade. And I know this height is 60 plus 12. It is 72. So when I draw my big right triangle, it's going to be 72 over there and 75 down here. And I can expect an angle that's going to approximate 45 degrees because this side is pretty close to this side, and if they were equal, that would be a isosceles triangle. That would be 45, 45, and the 90 over there. Since this side is a little bit less than 72, I know the corresponding angle is going to be less than 45 degrees. I'm going to call it like 42. But I'm just kind of talking. Let's actually do the math. I am now looking for this angle, which we'll call y. And it's still the same setup, the opposite and the adjacent, so it's still the inverse tangent. But now we're going to use 72, and we're going to use 75, and that will tell us our angle. So if I do the same thing, second tangent, 72 divided by 75. I was a little off. I said 42. It's really like almost 44. It's very close to an isosceles triangle. So 43.830. 43.830. The entire thing. So I'll do it in blue actually. This entire angle is 43.30. So to figure out this remainder theta, right, and I'm calling that the green, theta is going to come from taking the whole angle, which is 43.30, and we have to remove that small angle. We have to subtract the part at 9.09, and that will tell us theta. So if I take that into the calculator, I take that 43 point whatever, and I subtract it from 9.09027. That's enough decimals. I'm going to get 34.740. 34.740. 4.74. I'm just going to verify that's correct. Yep. And they want me to round to the nearest tenth. So the tenths place is that 7. I look to the right, that's a 4. So I eliminated it. It wasn't 5 or higher. The measure of angle theta, the projection angle, is 34.7 degrees. Thank you very much for attending Elias Academy, day 56, part 2 of our DRA review. I'll see you in class tomorrow.